morning. Well, if you are in grade 9, then you are in luck. We're going to spend a bit of time with the grade 9s going over some factorization, and we will look at the factorization accompanied by some simplification of algebraic fractions, so applying our factorization. So let's look at some problems here, and hopefully as we go over them we can pick up some things that may be important for a grade 9 learner. So let's jump into it. So you can see there the first problem has been done because we were told to factorize the following 18x minus 27. So guys, 18x minus 27, when we factorize 18x minus 27, we know that the first thing we always ask ourselves is, in the expression 18x minus 27, is there a highest common factor? So we identify that highest common factor, and when we do so, we look at the sign of the first term and the last term. We look at the number of the first term and the last term, and then we look at the variable of the last term, first term and the last term. So here the highest common factor, guys, according to our sign, the first term always dictates the sign that we take out, so it's positive. Then secondly, the highest common factor number between 18 and 27, so we know that it is 9, so we take out a9. Then when we take out that 9, we ask ourselves also, what's the highest common factor letter between the two terms? Now x is not common, so that's why we don't take it out. We always take out the common variable that has the lowest exponent. So what we have outside is 9, and then inside to that we have 9 times what gives us 18, it is 2. Then our x was also left over, so we write that x, and then we say 9 times what gives you 27, negative 27, you get negative 3. So 9 times negative 3 gives you back that negative 27. So this is how we were able to factor this problem. So we can clearly see that here we had to apply highest common factor. Okay, two terms where there's a highest common factor, we always look, can we take out the highest common factor sign? Can we take out the highest common factor number? Can we take out the highest common factor letter? And our highest common factor sign is always dictated or given by the first term. So if the first term is positive, we take out a positive sign. If the first term is negative, we take out a negative sign. So because it's positive, we took out a positive. Then we follow it up with highest common factor number. So we check between 18 and 27, what is the highest common factor between the number 18 and 27? So it is 9. Then we check again after identifying the highest common factor sign, the highest common factor number, we check what is the highest common factor letter or variable. When we check, we check in the two terms, do we have a highest common factor variable? Now it's very clear that we don't, because x, even though it's in the first term, there's no x in the second term. So therefore there is nothing that is the highest common factor letter. So we take out 9 because that is our highest common factor, it's positive 9. What's left over? 9 times what gives you 18? It's 2. Or you can say 18 divided by 9. It gives you 2. Then what else is left over for our first term? It's the x variable. Then you are done. It's 2x. Then 9 times what gives you negative 27? So obviously 9 times negative 3 gives you 27. Or you can say, what's negative 27 divided by 9? That gives you negative 3. Now that is fully factorized. We cannot go any further, because even if you look in the bracket, can you factorize any further? No, you can't. So we are left with 9 into 2x minus 3, and that's how we factorize the first problem. Let's go on to the second problem. We have x squared minus 121. Okay, so if we look at this expression, we ask ourselves, how many terms? 2 terms. Second question, is there a highest common factor? Now, guys, contrary to popular belief, there is a highest common factor. And sometimes it's important to acknowledge that in actual fact, the number 1 is the highest common factor between x squared minus 121. If we look at the sign of the first term, it is positive, so we must take out a positive sign. Secondly, if you look at the number, there's a number 1 that we don't see here, and the number 121 which is there. So we ask ourselves, what is the highest common factor number between 1 and 121? It is 1. Then, any highest common factor letter? Is there a common letter between the two terms? No. So therefore, it means our highest common factor is 1. Then inside the bracket, what are we left with? We are left with x squared minus 121. Now, here inside the bracket, can we factorize any further? That's the question. And the answer is yes. So having taken out the highest common factor, what else, what other type of factorization can we see inside the bracket? So inside the bracket, we have negative sign, which means difference. D for difference. Then x squared is what we call a perfect square variable. A variable raised to an even number. Any variable raised to an even number is called a perfect square variable. 121 is a perfect square number. Why? Because 121 can be formed by multiplying a certain number by itself. What is that number? It is 11. So we're here, what we have is a difference, because of minus, of what? Of 2 perfect squares. X squared is a perfect square. 121 is a perfect square. Remember, what did I say qualifies x squared as a perfect square? It is the fact that it is a variable, a letter, that is raised to an even exponent. Any letter raised to an even exponent is called a perfect square variable. Then 121 is a perfect square number. So we have a difference of 2 squares. So what do we do when we have a difference of 2 squares? We open 2 brackets. All right. Our number 1 is still there. Unseen, but there. We do not leave the 1 behind. But just because I did not write it down does not mean it's not there. Okay. Then, after opening 2 brackets, we take the square root of the first term, which is x squared. The square root of x squared, guys, is equal to x. So that means in my 2 brackets, I am going to write my x variable to populate the first term of each bracket. Then I'm going to move on to 121. What is the square root of 121? Ignoring the sign, of course. So the square root of 121 is 11. So what I do is I populate my 2 brackets with 11. All right. The last term in each bracket is 11. Then you're going to ask, what is the sign? So the thing is, this word difference, okay, whenever there's a negative sign for our last term, it means that we need to have different signs. Difference, negative last term, means we need to have different signs in the bracket. Thank you, Dipog, for the heart me. So that means we need to have a plus and a minus sign. Okay. So this is how we factorize this sort of problem. Okay. For those who are coming in, they are on their way to school, you are catching the live midway, I upload all videos of what I do on my YouTube channel. The link is in the bio. It's called Maths is a Game. Please go there to my link, to the bio. Click on the link in the bio, the YouTube link, not the WhatsApp link. There are 2 links, WhatsApp link, YouTube link. But you can join the WhatsApp link so that you can be part of the WhatsApp channel as well, so that when I upload videos on the YouTube channel, the clickable link will be found on my WhatsApp channel. Okay. So I upload these videos so that people can watch when they have time. The next question, this is x squared plus 12x plus 20. This is called a quadratic trinomial. The word quadratic. Okay. In actual fact, look at this one, B. This was also quadratic. This word quadratic has to do with when we have in our expression, the degree of the expression is 2. Now, so for some of you, when I say the degree of the expression is 2, it means in our expression, if you look at the variable, the highest exponent that exists in the expression is 2. That's what quadratic means. I repeat, quadratic means the degree of our expression is 2. And what do I mean by degree of the expression? It means the variable with the highest exponent. The highest exponent is 2. So this is quadratic, but because it's 2 terms, this is a quadratic binomial. Here, this is also quadratic because the variable with the highest exponent has an exponent that is 2. But we call it a quadratic trinomial. Trinomial means 3 terms in my expression. 1, 2, 3, because terms are separated by a plus and a minus sign. So how do I factorize this? First question I always ask, how many terms in the expression? There are 1, 2, 3 terms. Second question, is there a highest common factor? Between what? Highest common factor, sign, number, letter. So highest common factor sign. When we take out a highest common factor, we look at, is there highest common factor sign? Is there highest common factor number? And is there highest common factor letter? So we have 1, 2, 3 terms. We look at the first term. The sign is positive. Our first term always dictates the sign that we take out. So the highest common factor sign between these 3 terms is positive. Then we go and ask, is there highest common factor number? Between which numbers? 1, the coefficient of x squared, 12, the coefficient of x, 20, the constant term. So between 1, 12, and 20, the highest common factor number is 1. Then lastly, is there a highest common factor variable? Even though there's an x letter here and there's an x letter there, that x letter is not common for all 3 terms. So that means there is no highest common factor letter. So when I take out my highest common factor, I take out what? 1. And then what am I left with inside the bracket? X squared plus 12x plus 20. Right? Okay. Then inside the bracket, what do I notice? I still have the same expression, but instead of there being 1, 2, 3 terms, I now have in my expression 1 term. I refer to this as 1 term. Why? Because when you have brackets around however many terms, it makes it to become 1. Now, this quadratic trinomial, I can factorize further what is in the brackets. How? By opening 2 brackets. These 2 brackets that I open, remember outside the bracket, the 1 that I took out is still there. Invisible as it is there, guys. Right? Just because I didn't write down the 1, it doesn't mean it's not there. Okay? The only time I actually write numbers and I show them being visible is if outside the bracket there is a number that is not 1, then I actually show it. I write it down. But if there's 1 can remain invisible as long as it is not accompanied by a variable and a sign that is negative. So it can remain invisible. I did not drop the 1. The 1 is still there. Then how do I factorize what's inside the bracket? There is these 2 brackets. So then I need to first figure out what are the signs inside my bracket. Guys, it's very simple. You see, whenever your last term, as you look inside the bracket, you have a positive x squared, you have a positive 12x, you have a positive 20. Whenever inside your bracket, the last term, that is your constant term, right? Or your last term, okay, that has the least variable, that has the least value, because you have an x squared term, x, it's like we're descending 2, 1, no x. So what we do is we establish the sign first. Inside the bracket, guys, since we have a positive sign, it means we are going to have the same signs. So positive means same sign. The positive for the last term means same sign. But what sign is it going to be inside the bracket that is going to be the same? We look at the sign of the middle term, our x term in this case. All right. So our x term has a positive sign. So that means the same signs that we're going to have inside the bracket will both be positive. So I see someone saying, sir, what if this middle term had a negative sign? How would the signs be inside the bracket, both of them? The signs, both of them inside the bracket, would both be negative. Okay, so what we look at is our last term. If the last term is positive, that means same signs. The question is, according to who? According to the sign of the middle term. So if the sign of the middle term is positive, it means positive, positive. For my Xhosa speaking learners, I usually say to them, plus for our last term means siyafana, meaning we are the same. And the question is, who are we the same? According to who are we the same? We are the same according to the sign of the middle term. So therefore that means our signs inside the bracket will both be positive because this sign is positive. If we had a positive constant last term and this sign was negative, we'd still say we are the same. According to who? According to the middle term. And then we would write a negative and a negative. But here in this situation we have positive 20, so that means we are the same. The question is according to who? According to the sign of the middle term. So therefore, positive, positive. Then, what about x squared? How do we form x squared? Guys, the square root of x squared, we have x and x. Okay. Now what we need now is the last term. And the way we get the last term is we need to find the factors of who? Of 20. The factors of 20, the last term, these factors, when we multiply them, they need to give us 20. But when we add these factors, they need to give us 12. So the question is, which two factors of 20 do that for us? So we write down our factors, okay, of 20. And we ask, what is the factors that we know of 20? Okay, so 1 and 20 are factors that go together. Okay, just to answer the question in the comment section, those who are asking, do I offer online classes, extra classes? I do, guys. Just send me an inbox. I'll get back to you. Okay, I'll get back to you. Please, you can do that. Okay, message me on the side, DM me. So factors of 20, 1 goes into 20 how many times? 20 times. So we have these two twins that work, that actually are factors. Okay, 1 and 20. What are the others? If we look after 1, the next number after 1 is 2. So 2, but goes into 20 how many times? 2 goes into 20 how many times? 10 times. So we have another pair, 2 and 10. Let's think of others. 3, no. 4, yes. 4 goes into 20 how many times? 4 goes into 20 5 times. And I think that's about it. So another pair that we have is 4 and 5. Now we know, because we've already established the sign inside the bracket, both of these need to be positive. So then the $1 million question is, which pair of factors, when I add them, give me the middle answer, which is 12, the coefficient of x? Which one, when I add together, gives me 12? Is it 1 plus 20 that gives me 12? Aye, corner. Is it 2 plus 10 that gives me 12? Yes, corner. Is it 4 plus 5 that gives me 12? Aye, corner. So which one do I choose? It's this one. It works. It works. It's 2 plus 10. The multiplication of these, all of them will give me 20. But there's only one which, when I add, will give me 12. It is 2 and 10. So I go back to my bracket and I simply write 10, 2. And there it is, guys. I have factorized this trinomial, fair and square, no matata, right? Hi guys, I don't know if you can see this. This is beautiful. So factorization is straightforward. If a trinomial, if it's quadratic, all right? Now I know that in this question we don't have a situation where we have a negative sign for our last term, but I just want to indicate that if your last term was negative in your after you took out the highest common factor, you still had a last term that's negative. That would mean different signs inside the bracket. Okay, so positive for your last term means same sign, but negative for your last term means different signs. We are not same. We are not the same. But plus 20 positive for your constant term means we are the same. We are the same. We are the same, guys. We are the same signs inside the bracket. If the last term is positive, it means we are the same. What are the same? The signs are the same. According to who? According to the sign of the middle term. We are the same. According to who? According to the sign of the middle term. We are the same. Positive for your last term means we are the same. So if you have a positive sign, it means we are the same for the brackets. According to who? According to the sign of the middle term. So that's why we have plus and plus. But what if we had a negative last term? Then it means we are not the same. We are not the same. Let me quickly just look at an example like that. Look at this one. X squared minus 5x minus 24. Negative last term. What does it mean? We are not the same. But before that, we always first ask, is there a highest common factor in these three terms? Because there are three terms. Is there a highest common factor? Yes, there is. It is 1. We take it out. Okay. Then it's what? We have x squared minus 5x minus 24 with the 1, which is the highest common factor, taken out. Then the next step, we look at the trinomial inside the bracket. What is the sign of the last term? It is negative. So what you do is you open the two brackets. Remember that 1, it's still there, right? Okay. We still keep that 1 there. It doesn't disappear. Okay. Okay. Remember, we can actually not write it, but it still means that it's there if it is the number 1. But if it was something else, guys, maybe it was 2, that was the highest common factor, we need to make sure that that 2 is visible and we can see it. So negative means we are not the same. The last term, if it's negative, it means we are not the same. Okay, for my Xhosa learners, asifani, we are not the same. We are not the same. Okay, but here's the condition. We are not the same, but the factor of 24, that is the highest, will adopt the negative sign. Hey, listen to this. But the factor that is the highest will adopt the negative sign. Hey, we are not the same. Okay, so I'm going to write negative, positive. But the factor of 24, that is the biggest, will have the sign that is in the middle. So since the sign that's in the middle is negative, we know the factors that we choose of 24, which actually when we multiply give us 24, and when we add give us negative 5. The factor that is the highest will have the sign of the middle term. Okay, so this is how you need to think about these things, guys. And there's no reason why trinomials should be such a pain. Remember, as a grade 9 learner, if you have not mastered factorization, guys, pure maths in grade 10 and 11 and 12 will be painful. It will be such a pain. You will not love maths. You will hate maths. So you need to master factorization. You need to become the master of factorization. So 24 has many factors. We have 24 and 1. But I mean, I'm sure if we're making the biggest factor of those numbers negative, which is negative 24, adding these two doesn't give you what? Doesn't give you it doesn't give you negative 5. We have 8 and 3. We have 6 and 4. All right. We have 12 and 2. If we make all of the big factors out of the pair negative, right, that means the other ones, the smallest ones, will be positive. Because remember, we are saying that we are not the same. We are not the same. We are not the same. Negative for the last term means we are not the same. but the condition, the highest factor must have a negative sign. If there was a plus here and we are having a negative constant last term, we still say we are not the same. But then if this was positive, we'd say the highest factor out of the factors of 24 must have a positive sign. So which one qualifies here? Negative 24 plus 1 doesn't give us negative 5. Negative 8 plus 3, ooh, this one works. This one works. So we choose this one. Let's check. Negative 6 plus 4, the addition of these two doesn't give us negative 5. Negative 12 plus 2, the addition of these two doesn't give us negative 5. So it's negative 8 plus 3. And remember, I had already indicated my signs. I knew that the highest factor out of the factors of 24 must have the negative sign. So I have 8 and 3, and then this side, key x, and this, guys, has been fully factorized. Okay. Now, guys, thank you so much. Thank you for joining in. I hope you guys can attempt number H, the letter H for me. You can attempt I, you can attempt E, you can attempt D, because factorization is popping for you. All right, but I will continue with the rest tomorrow morning, 6:30, same time, same place. Maths is a game. Love you lots. Please take care. And yeah, let's master the maths. Let's play the maths. Let's practice the maths. Let's play it, and hopefully by playing it, guys, the more we play it, the more we enjoy it, the more the marks come. The level 7 will come. It has no choice. Level 7 must come. It has no choice. It has no choice. It has absolutely no choice. Okay, thank you so much, guys. Have a beautiful, amazing, sweet morning. If you are a learner, you're going to school, enjoy your journey at school. Please pay special attention, especially now in this season of life as June exams are approaching. Pay specific attention to what you are being taught, and any key important things that your teachers say, pay attention to those things, and prepare. You have a few days now. The countdown is on. Like, I think it's less than 10 days till some of you start writing your actual exams. Some of you are starting next week. So please, guys, let's buckle down. Let's prepare wisely. Let's prepare so that we do not regret the time and the effort put in that preparation. Guys, you may see here in my comment section, all right, for those that might be like, well, sir, past papers, no. There's a guy here in the comment section, Smart Study, okay? The account there is Smart Study in the comment section. All right, please, guys, he uploads the question papers for various subjects, not just maths. So in my platform, you might see occasional papers being uploaded, but Smart Study, what he does, he uploads. Smart Study account on TikTok uploads all other types of papers for all the other subjects that you may be doing, whether that be grade 12, grade 11, grade 10, grade 9, grade 8. Check him out. Check out the papers that are uploaded there. So as you prepare yourself, use those question papers and utilize them to prepare for your June exams. Thank you so much. It was great. Have a good one. And remember, to those who actually came into the live for the first time, follow the live creator. Secondly, gift when you can. It would be epic. And also thirdly, my YouTube channel is up and running. You can also check out my YouTube channel. All the videos that I do in the live sessions are always uploaded there. I have a playlist currently for grade 9s, which is called the June exam build up, and everything that I do here in the mornings, the 30-minute segments, I upload the content that I cover here onto that playlist so that you can review it, check it out in your own time when you want to. Okay, leave you. Have a great day. Cheers.